Okay, these are the notes for section 2.1 on direct variation. Hooray for chapter 2. I know you're all very excited about that. Here is your journal choice. I think a lot of you will choose to do this one because it's pretty simple. Okay, objective and what's the point? This chapter is all about relationships, and this has so many applications to the real world because so many things are related and we use these relationships to make predictions. I feel like this chapter was very hard for me to teach the first time that I taught it because this was new to me. But now that I've taught it a few years, I absolutely love it. I love the applications, and I think you guys will too. It will really help on your science portion of your ACT as well. We are going to today introduce language and logic of direct variation. There are some processes that you're going to have to memorize, but the more practice you do, the better you'll be at that. Okay, words to know. Direct variation equation is an equation where both variables or quantities increase or decrease together. We say one quantity, which is the dependent variable, varies directly as the other quantity, which is your independent variable, or the dependent variable is directly proportional to the independent variable. Okay, this is the important thing you need to know. If it's direct variation, they vary directly. What I always ask myself is, are they both getting big together or are they both getting small together? If one gets big, does the other thing get big? If one gets small, does the other thing get small? And that will be a key that it's probably direct variation. If it is given to you in words, you are looking for these two key words. Varies directly as, good underline there, and is, oh my gosh, that's horrible. Pretend that's good. Is directly proportional to. Okay, if you see those two words, you know that it's direct variation equation. Once you establish that it's direct variation equation, you will know exactly what to do because there's going to be these steps that I'm going to give you here on the next slide, and it's very easy from there. Okay, this is what you do if you see as direct variation. As soon as you figure out they're getting big together, or it said those magic words, you will write down this equation, y equals kx to the n. You need to memorize this as your direct variation equation or direct variation function, and anytime you see those words or you notice that the quantities are related, you will write this formula down on your paper first thing. I do it every time, and I've done a lot of these problems. Okay, it's a direct variation function if it follows this pattern. Okay, k can't be 0, so I can't have y equals 0, because notice if k was 0, then you wouldn't have an x anymore. And n has to be positive. Okay, you can't have negative exponent there. These are all examples of direct variation. W equals 52/11 p, because look, it follows that form. Y equals k x, in this case to the first power. So we have our dependent variable here is w, our k value, because k is just a constant, it's just any old number, 52/11, and your independent variable here is p. Okay, same thing here. Y equals kx to the n. It follows the form, so we know it's direct variation. Dependent, k value, independent, and in this case we're talking about n is the first power. Y equals kx to the n. Y matches with the a. This time our constant is pi. That's okay, pi is just a number. Our x and r match up as our independent variables, and this time the n value is 2. This one is pretty obvious because it's y equals kx to the first. Same thing with y equals kx squared. Okay, k is a very important part of these functions. It's actually going to be our goal to figure out what k is almost on every single problem, and it's called the constant of variation. These are so fun. You're going to like them. Okay, this is the most important slide. I would definitely pause the video or at least write this down. You need to know these steps. Okay, this is straight from example 1 of your reading in your textbook. I have that being on page, here it is, page 73. First thing you will do to solve these problems, write the general variation formula with the variables they give you. So I always write this down first, y equals kx to the n, and then underneath it I substitute the variables in. But if you just want to substitute the variables first, that's fine. But on the first few, I'm going to suggest that you write this general formula down first. The only thing tricky about that is you will have to determine which one is independent and which one is dependent, because it will definitely matter which one goes in which place. After that, in the problem, they're going to give you some sort of code. You're going to plug in the info that is given to you. So they're going to say, and you'll see in a minute, when y is 20, x is 4. You'll plug it in. You'll use that information and you will solve for k. So your step 2 is to figure out what k is. After you figure out what that constant of variation is, how these numbers are related, because that's really what the constant is telling us, you can then write the formula with the newfound value of k in. So you'll plug it back into your formula 1 with an actual number for k, and then you can, the fourth thing is use that new formula to answer the question that they ask you. I really, really like these a lot. Okay, so I hope you read through example 1 on page 73. On this next slide, we are actually going to do an example very similar to it. I want you to go ahead and pause your video now and try to work through it on your own. I will give you the answer in 1 second, and then I will work the entire problem out on a blank sheet. You're welcome to fast forward that if you want, if you get the right answer. Okay, so here's the problem, and here is the answer that I got. I have 384 square centimeters. Okay, if you got it, you're welcome to move on, but I'm going to work this problem out right now. Okay, I'm going to start it right here. The surface area S of a cube is directly proportional to, I see the words, directly proportional to, and immediately I'm going to write y equals kx to the n. Those words tell me, write this down, so I did. Okay, now the second step says to fill in the variables they give you. Okay, so that's what I'm going to do next. The surface area S of a cube is directly proportional to the square of the length E of an edge. They're telling me surface area depends on the length of an edge. So this is going to be in place of my y. This is going to be in place of my x. So I now have S is, remember is means equal. That's a good way to tell which variable depends on which. S is directly proportional to, that kind of tells you there's going to be a k here, the square of the length. So that tells me E squared. I'm telling you, my students always read over this. So be really careful that you find out what that exponent is. Super important. Okay, so this is the formula. After that, they're going to give me some code. I got to figure it out. The question is, what is the surface area of a cube with an edge of length 8 centimeters? That's the question part. This is the code they're telling me. If a cube with an edge length of 5 has a surface area of 150, they're telling me, guess what? One thing I know for a fact is that when E is 5 centimeters, S is 150. That's really good to know, because now I can plug in S is 150. Still don't know what K is, but I know that E is going to be 5 in that case. That's squared. Now I can figure out what K is. 150 equals 25K. Divide both sides by 25. And I get K equals 6. I am not done. I have not answered the question they asked me. Okay, what do I do with this K value? I go back to this equation and I plug it in. Okay, so I'm going to actually do this over here now. The bad thing about these flip charts is I never quite have enough room to do my work. Okay. So I'm going to plug this back into this equation. So now my new equation is 6E squared. This is the relationship, you don't need to see that. This is the relationship that this cube has. So now I can answer any question I want. But the one they're asking me is, what is the surface area of a cube with an edge length of 8? So now I can plug this in for my edge length, E. S equals 6 times 8 squared. S equals 6 times 64, and I get what I just told you, 384. What am I talking about? Square centimeters. Okay, I hope that makes sense to you. You'll get better, lots of practice. Again, in a nutshell, oh, pen's marking up the page here. Not even doing that. Write the equation, fill in with the variables, figure out what K is, use K to rewrite the equation, answer the question. Okay, that was fun. I hope you liked that. I did. Good times. Okay, next one. These are more straightforward, and as a rule, kids usually think this is a little easier, but here we go. There's no extra words. Suppose M varies directly. Oh, that tells me to do what? Write down this formula, y equals kx to the n. As the fifth power of p, if m equals 96 when p equals 2, find m when p equals 5. You can pause this and work it out on your own right now if you'd like. The answer I get is 9,375. Okay, here's my explanation. You can fast forward this part if you got it right. Okay, so I wrote y equals kx to the n because I saw those keywords varies directly. Now I plug in the variables. M varies directly as the fifth power of p. So m is going in for the y. K will still be there, and now I have p to what power? The fifth. Look for the piece of data that matches, and here it is. If m equals 96 when p equals 2, here's my question. I'm not doing anything with the question till the very end. Find m when p equals 5. So now let's plug in the set that they tell us they know is true. When m is 96, still don't know what k is, but p is going to be 2. 2 to the fifth. 2 to the fifth power is 32, so I have 96 equals k times 32, which is the same thing as 32k. I can now figure out what k is by dividing both sides by 32, and I have a k value of 3. Is that what they're asking me for? No, that is just what the constant is. I need to use that constant to plug it back into my equation here. M equals 3 p to the fifth. And now I can easily figure out what m is when p equals 5 because I just plug in 5 into the p spot here. 5 to the fifth. And I get, I just told you before, 9,375. And again, look, from 2 to 5 it gets bigger. What should happen? 96 to 9375 should get bigger. Direct variation, they both get big together. That's a quick way to check your answer. Okay? The last example I'm going to go over with you is they're going to ask you if it's direct variation or not. Here's what you can ask yourself. Are they getting big together? Are they getting small together? Okay? If one is double, is the other going to double? That is if it's a general y equals kx example. Okay? But really you're asking yourself if one is getting big, is the other getting big? Okay? The cost C of n fish sandwiches. Is it going to cost more money if I buy more fish sandwiches? Yes. So is that direct variation? Absolutely. The amount of time it takes you to run at top speed. Okay? Is my time going to get bigger if my speed gets bigger? No. If my speed is quicker, my time should be less. This is not direct variation. Okay, how about this? A and R. Am I going to ask myself this question in this case? No, I'm not. I could, but it's not going to be that helpful for you unless you really have a good picture of this area of a circle, which some of you might. I'm going to see, does it follow my template? Y equals kx to the n. This means it will be direct variation. Oh, why does it do that? Y equals kx to the n. Is that direct variation? Yes. How about this one? Y equals, oh, there's no k. Is that direct variation? Well, I say yes, there is a k, you just can't see it because it's a 1. This is direct variation. That one's tricky. Y equals kx to the n. How about this one? Y equals kx. Is that okay that there's no n? You should say, Mrs. Bruno, yes, there is an n. Oh, look, it's 1. There it is. So is it direct variation? Yes, it is. How about this one? Y equals, oh, there's 3 things. Remember, k is just a number. 2 pi is also just a number. It's just a weird way of writing the number. This is y equals k, which is 2 pi in this case, x to the first power. This also is direct variation. How about this one? P equals 2L plus 2W. Is this direct variation? This is a huge indicator that no, it is not. I don't see a plus sign anywhere in my general form. It is not direct variation. So this one, obviously, for the same reason, not direct variation. Okay? We also have another example. Nope, we just don't. On with the good stuff, math candy. Good luck with your homework if you're going to start early. If not, please be ready to go when you get to class tomorrow. See ya.